Okay, so question name for the following compound. So let's also draw this compound down here. So this is an organic compound, and specifically it contains mainly hydrocarbons, or only hydrocarbons. So this means it only contains carbons and hydrogens. Okay, so it looks kind of like this. And when naming these types of compounds, the first step is to find our parent chain. And to find your parent chain, we basically want the longest chain with the most important groups. So typically when we have an organic compound, sometimes there are other functional groups such as alcohol groups or double bonds, triple bonds. And this is what I mean by most important groups, like those functional groups. But for our example, we only have a chain of carbon and hydrogens, so we're only looking for the longest chain in this case. So a common mistake I see people make is they just think that the longest chain is the one that is like horizontal like this, like the easiest one to circle. But if we counted out how many carbons are in this chain, you only have 5 carbons. So this isn't the longest chain that we could form with this compound. The longest chain, in fact, involves these carbons as well. And then we kind of want to circle it so that we can visualize the chain. And then when choosing to go up or to the side or down, notice that if we go down, this is also the longest chain as well. Okay, so here I have circled the parent chain, which is the longest chain with the most important group. So in this case, it's just the carbons. So the second step is to number our carbon chain. And in the end, we want the lowest number possible when designating where all the side groups are. So I'm also going to add a step 3. This will help us number the carbon chain. Step 3 is to identify our side groups. So these two steps can kind of be merged into one, because if I identify my side groups, I'll see that I have 2 methyls here and another methyl here. So every time we have just 1 carbon with 3 hydrogens as a side group, this is called a methyl side group. And when I want to number the carbon chain, I mentioned earlier I want the lowest number in my final answer. So notice that if I can either start numbering from here and make this 1, 2, 3, 4, 5, 6, 7, 8, or I can start numbering from the bottom and number this as carbon 1, 2, and then 3. So notice that 2 of my methyl groups are on carbon 3 if I started counting from the bottom, but if I started counting from the top, this would be carbon 6. So therefore, if I start counting from the bottom, and this is now carbon 3, then in the end, when I name my compound, I'll have the lowest number possible. So therefore, I know I need to start numbering from the bottom there. Okay, so that was step 2 and 3. And now step 4 is to finally name our compound. So we want to name our substituents first. So in this case, these are the methyl groups, and I have 3 methyl groups in total. So to show which carbons my methyl groups are on, this is where I would number. On carbon 3, I have a methyl, and also on carbon 3, I have another methyl. So I have to write 3 twice to show I have 2 methyls there. And also on carbon 5, I have another methyl group. So I write 3, 3, 5. And then to show that these carbons contain my methyl groups, I put tri-methyl. Since we use the prefix tri to tell us that there are 3 of it. So 3, 3, 5, trimethyl. And then again, our parent chain would be named last. And since our parent chain is 8 carbons long and it only comprises of single bonds, then I know that it is 3,3,5 trimethyl octane. Yep. So this is our final answer. Okay, so the junior tutor said that in naming alkanes, the parent chain corresponds to the longest possible chain of the compound, and the prefix used for the name varies depending on the number of carbon atoms comprising this chain. The table below shows some of the prefixes used in naming alkanes. Note that the prefix is added to ane, which is the characteristic name of an alkane. So alkanes are single bonded carbons. Okay, so they summarize all the different parent you could have and the name of that alkane. So in our case, since we have 8 carbons, this is where the octane came from. After naming the parent chain, assign locants to the chain in such a way that the substituents get the lowest number possible, and then name them. If it is an alkyl group, the prefixes shown in the table also apply. Instead of adding ane, you add il. So here we have the meth, and then since it's a side group, we add il instead of ane. In the case of the given compound, the longest possible chain is composed of 8 carbon atoms. So the name of the parent chain is octane, and the substituents, on the other hand, are alkyls composed of only 1 carbon atom, so their names will be methyl. So they color-coded the parent chain in red and named the compound 3,3,5-trimethyl octane. Okay, so this solution is correct.